test. Remind me later. Test. Okay. We're live. Hello, everybody. I do not know the problems. I was busy now. And why doesn't Twitch title work? This is Codeforces TypeDB live coding. And the link. Okay, fixed. I will start coding when this timer runs out. I already see the difficulties, so I know that this is basically sorted. I think in maybe 2 hours I will manage to go up to F. I'm aware that I'm not able to submit just after the contest. So I will just create code and then move to the next problem. Once I'm able to submit, I then will realize what I'm doing, what I did wrong or not wrong. I need to remember that in cast.io, that software for double streaming, changing the title doesn't do anything. Both in YouTube and in Codeforces, the title was all messed up. Oh, and in YouTube I wasn't going to create, allow the live chat. I think I will turn it off later. Only on Twitch there is a live chat. Sorry about that. Big difficulty gap between BC. Yeah, the number of accepted submissions shows that. Okay, so let's go. Yes, I didn't participate. I will have a stopwatch to measure my times. I don't think I can submit yet, but I will just save my codes. The only preparation I want is just opening a.cpp. And I think let's start. Stopwatch start and go. I couldn't participate, I didn't have time. Well, we will not use big numbers if they need to sum up to n. One of them will be 1. So let's say x is 1. It's 1 at power y, so just 1 times y plus y is equal n. Okay, that's one possibility. Otherwise, if both are greater than 1, they will be very, very small. So, and if n model 2 is 0, then print 1 and n over 2. Does that work? Yeah, that works. Else, only small values. 30 should be enough. Half from 2. I don't want to use power function. What I will do is I will create my own power function. Power generally is not safe, it's unprecise. So we have power of xy plus power of yx. If TMP is greater than n, then break and continue to the next thing. If TMP is equal to n, then great, print x and y, return, and if you got to the end, print -1. (121). Those are very weak tests. Well, what did I type wrong? Wait, times 21 times 1. I think I'm doing something stupidly. No, 32. Okay, let's test this for anything else, like, or is it? Because otherwise maybe it cannot be odd or something like that. Now I would just submit. Maybe I can submit. Can I submit? I should be registered for the contest. I cannot submit. Infinite loop, or what is going on? Why doesn't it print? Do I need to say this? What am I doing wrong? Why does it print it at the end? This doesn't affect cout? What's going on? I only recently switched from print-scanf to this. Well, I don't want to waste time now. I will just modify this. 1, 2, 4, 5. I don't know. I don't have really good ideas. I think this should be enough, and I will just move on. Cout.flash. Okay, it works, but I don't like it. Let's move to problem B. Also 5 minutes. I will maybe write it at the top. It's my time for A. And is the product this is like factorization of a number. It's just that AI can include a lot of numbers. Maximum value of this. Should I just factorize n? Not necessarily. Okay, we need to write a number as the product of its divisors just to maximize the value. Should it always be the product of two things? Because this, where you can say 100 is 10 times 10. Usually when you need to write number as the product of two things to maximize x plus y, those two things should be as close to square root as possible. But then this would be bigger. Why is it so small? Product of distinct prime numbers. Can't I represent this as, I see, 2 at power 1, 5 at power 1. Sorry that I'm not looking so much in the chat. Maybe later. I do not know the problems. I didn't have time to participate, so this is my virtual participation. You can discuss solutions in the chat, but I will not read it. Maybe later with more difficult problems I will have more time to look in the chat, but I will try to here explain my logic. Why for this number I cannot say that this is 2 at power 1 times 5 at power 1 times 2 at power 1 and so on. They don't say that AI needs to be distinct from each other. They say that it needs to be a product of distinct primes. Am I misunderstanding the statement? Do they mean that AI needs to be distinct from each other? Oh no, but the sum of those will be 90. Never mind then. Okay, I mean, or less. So 2 plus 5 versus 2 times 5. 2 times 5 is better, and generally it's good to take a lot of things. So we will just greedily take as much as we can, and that's it. If some number is, let's say, 2 times 2 times 2 times 3 times 7 times 7 times 17, I will, as a first number, use 2 times 3 times 7 times 17, and then I will continue. Piece in my solution will always be equal to 1, because this way I can get big numbers. That's my solution. And if it works for the sample test, I will assume that it's good enough. So let's find prime divisors. This thing in square root of n time will find all the, it will just find factorization of n. Like 2 at power 9 times 5 at power 9. Good. And now repeatedly, I don't know, 30 times. Or just while true. I will get product of all numbers where still some exponent exists. For all the pairs, if second is greater than 0, multiply by the prime and subtract 1. If this product is 1, meaning we are out, then break, otherwise add product to the answer. And this works. Time, this is 12:00. I don't think can submit. And I'm very slow so far. C. Those Codeforces rounds, at least easy problems, are very muffy nowadays. So far, third problem about math. So we split A as the sum of two things, and also this needs to be true. So perfectly x and y will be close together because we want this to be big. Or we want both values to be negative. Yeah, still, the closer they are together, the better, I think. Oh. I'm sure that this has some interpretation. Maybe not. A drawing might be necessary. When you have products of numbers, sometimes it can be area of a rectangle or something like that. We need to minimize f. So there is this, A is split like that. If one value is big, then in the other value we want to split it in such a way that this is small. Unless the next value is also big. What is this crazy problem? So let's say A1 is 5, A2 is 3, A3 is 10. So A1 I will split as something, let's say 1 plus 4. This gets multiplied by 5. Then 4 gets multiplied by something from the 3. Let's say this is 3 plus 0. This is how I represented 3. This is how I'm representing 4. This is how I'm representing 5. So it's like saying that there is 0 on the left. 0 times, and there is 10. I think this is optimal. There's also that crazy condition. What does it mean? It means that it cannot be true that one of those values is negative and the other is positive. If x is 0, then this is negative. And by making this big, this is positive. So it just gives us some range. Yeah, it will just say that xy cannot be below something, I think. Right. Say x minus 5, y minus 5. They need to be like that. It cannot be true that this is negative and this is positive. Let's say if x is 0, then y is big. Let's say y is 7, and this is bad. Actually, right now it would always be bad. Well, unless x is 3, y is 4, then this is good. What if it's not 7, but rather 17? But if x is 5 or bigger, then this is okay. It will say that x and y are at least something. And that's it. So either the lower limit will be s or ai minus s, I think. But that... Can I transform this a little bit? Shouldn't that be dp, where always for every split I will want the first minimize first number or the second number, because I know that this or this is smaller. Yeah, this can be done with dp. Oh, also I've just realized that I can see this. I will turn this off because I don't want to spoil, but I thought dp before looking at that. I need to find this somewhere in Codeforces settings. Show tags for unsolved problems. No. Yeah, because the thing is, once everything is fixed, if we look at that, y2 or x4 will be smaller. So here it will be optimal to either put everything into the left part or the right part. So I claim that this will be 0 or this will be 0, if possible. Well, if both are negative, then that's fine. So one of them will be s or one of them will be 0. It's something like that. I wonder if there is something smarter I can do. For such an easy problem, I don't like that it's dp, because people in Division 2 will struggle with that. dp is better for slightly more difficult slots. Well, I will always have possibilities for, should that be a map? Map. This will say dp from previous multiplier, and it will give me the minimum sum. Initially, previous multiplier is just, well, a1 is split like that, so I should say a1 and that's 0, of type long, whatever. Now for every element up to n-1, I will do something, and then eventually I need to multiply something by a of n. Just infinity is fine. For everything in dp, answer minimize with what p second plus p first multiplied by the last a. And now I need to create new dp. And do the transitions. For every possible, like the last multiplier, I will now consider this new split. And I need some formula using s. The new thing AI, I will split like that, or like this, or this, or that. I think those are the only possibilities. Where those are always okay, and these are okay as long as this is non-negative. So if x is greater or equals 0, y is greater or equals 0, then I know this is okay. In all those cases, the product will be exactly 0 because we know that's optimal. Because it's better to put everything into one side, left or right. That will minimize things. Is that sure? Yeah, depending on this comparison. Okay, and now new dp of y becomes dp of p dot second plus p dot first. That's the multiplier from this state multiplied by x, and not really equals to. This is, let's say, tmp. Now if this doesn't contain what y, then just put it there, else minimize it. That's a lot of test cases. Very strong samples today. Well, one value was correct. Nothing else. First test is here, second test. I'm guessing that What's special about the test here? Is it so different than everything else? Well, let's focus on that. Zero, and it should be 18. A lot of zeros. Okay, first, it claims that if we want to split the first element, the first multiplier is exactly that. So the first multiplier is 5. It makes sense that those are all multiples of 5. And then here we are saying that this first element I can split into 0, 3. Is that okay? What's s? S is 1. Then this is invalid. Oh, this is not necessarily good. Because 0 minus s times that, yeah, that's bad. So if x minus s is lower than 0 and y minus s is lower than 0, then the product will be positive. So continue. Nothing changed. 0 and 3. No, if both are negative, then it's okay. The issue is if this is happening, well, or the other way around. I can just, I guess, multiply, right? Should be 18. And the values are too small. The first thing, it splits using 1 and 2, which I can believe, but then it decreases. Well, certainly it shouldn't do that. I have a wrong transition, because that's p that's second, not dp, p that's second. Okay. 270. Let me just save the output and diff that. Yep, it's the same. That's time. I was never so slow. Half an hour for the first 3 problems. I'm guessing that people in the top did Kosaga solve things out of order. Yeah, he solved H. I should have done that in 20 minutes. So it's not that bad. Okay. D. Or maybe I will summarize the solution for C for you. The solution for C is based on this main observation. You know that there is some optimal sequence. Where's my pen? And if in the optimal sequence, in particular, you have something like plus, let's say, 5 times xi plus yi multiplied by 8, and then you continue, then knowing this and looking at choosing xi, yi, you know that you need to split ai into those two. If you want to minimize the sum, you need to look at the fact that 8 is greater than 5, so you want this multiplier to be small and this to be big. If possible, you want to put everything into xi. So xi should be the biggest possible value, allowing us to satisfy this inequality. Okay? But it's not that it will be like ai divided by 2. No, it should be the biggest. It should be so big that we cannot go bigger by 1. Or, you know, if multipliers are the other way around, then it will be swapped. So xi here and yi, they can be 0, because then you cannot go further away. Also, it can be such a value that this will be 0 or this will be 0, and maybe if you increase something by 1, this will go into negative. So it should be such a value that changing it by 1 will make a sequence invalid. And that's only possible if x or y will go negative, or they will break this formula. Hence, I checked cases where this is 0 or where this is 0. Because I know this is still okay, but shifting by 1 would be not okay. No, let's do D. When you're in some point, you need to jump to the right by AI. We can, before the game, modify something. Oh, they can be negative. Find the number of possible changes such that we will eventually stop, meaning we will go out of range. Okay, that's some kind of a directed graph problem. We're given a directed graph with some edges, and maybe this graph has a cycle. Now we want to change that. First thing, one of those nodes where I am, I can change to a value that will go immediately out of bounds, or I can change one of them to get me somewhere where after starting there I would go out of bounds. So for that, I think for convenience I will create a fake node, call it n+1. And if something points outside, let's say it will point here, and then I will wonder what nodes eventually lead to n+1. I will run backwards DFS from n+1. This will easily find nodes from where you will go out of bounds. And then, and what if already one is such a node? Yeah, so it seems that the task is easier for me if initially there is a cycle. Now, if initially we go out of bounds, then that's tricky. We can change anything that doesn't affect us, or we have that path to the end. Let's say there is a path 1, 7, 4, and that goes to n+1. Then it is allowed to make the following changes. For any one of those, we can just say that it now leads to the outside world, or I mean to anything in the future here, like that. Also, we can just change anything else, like here there was 5, it led somewhere, and now it can lead anywhere. Also, we can say that from any of those, like from 1, 7, 4, it leads somewhere, some kind of x, where it also anyway goes to n+1. What shouldn't count is going in this path, going back to something like this, because we are creating a cycle. Okay, so in this case it's easier to count cases where cases that will be bad, because if there is this path of length, I know k, then there are something like k choose 2 possibilities of changing it, so it would be bad. Like here, 1, 7, 4. The number of possible bad edges is 1, 2, 3. Can we do 0? Yeah, there are self loops. So also like that. How many right things do I have? 6. So the formula will be k plus 1 choose 2. If there is a path of length k leading into n plus 1 from the start, then k plus 1 of choose 2 is the number of bad moves. Everything else is good. And here I will count good moves because I need to change one of those. And there are, like, let's say k of them. I will need to count the number of visited things if we start from 1. In both cases I need to do that. I just need to detect if it's a cycle or not. And if this is k, then for each of them, so k, I will have possibilities for where they can be moved. So I will, let's call that good. And that's something that is outside, like maybe this, maybe that. In particular, n plus 1 is big. Yeah, that's enough for me to start coding. And those two cases, I will try to make code that works for both. Like, I don't want to repeat a lot of code. In particular, we need to know this initial path and the inverse graph to say for everything if it reaches n plus 1. Is there a better way? There are other ways, but I will just do the reverse graph. I find this problem easier than the previous one. It was more difficult to analyze, but I immediately know where to go. I wasn't stuck. I feel more confident using their indices from 1 to n. Go from 1. No plus equal a of node if this is visited, then if cycle is true. I'm going from node 1 and I check if I got to a cycle. Also I check if I got out of bounds. So if it's not true that node is in this valid range, then I break. We have some kind of k. For now, let's just print k and the cycle. Infinite loop. I'm not inserting to visit. No. But this should be infinite loop. Oh, break, of course. If it's a cycle, I never stop. Okay, we have some combination of falses and truths. We don't really have drawings, so I will just try to implement everything and then see if all the outputs are okay. I'm not going to submit now. I don't know if already submitting is possible. I will stop when I'm done with D, maybe then I will try to submit everything. Just after the contest ended, it was impossible. So now, if not cycle, then almost all the moves are good. So there are, for each of n positions, you have that many possibilities, and we need to subtract bad things, which is k times k plus 1 divided by 2. That's the number of ways for edges to go back. print all and return. In the other case, print question mark for now. Ooh, that's bad, that's dangerous. 35 instead of 34. I'm sometimes mistaken by 1. That's very bad. Let's look at one of those tests. Second one is here. 9. Yeah, it's just -1 and 0. So this simply goes outside. Oh, right, this is not enough. Why did I think for a moment that this is enough? I even said something about it. In this case, when I change an edge from one of those to the outside world, it needs to be to somewhere from where we will go to n+1. Yeah, of course, so that's not finished. Well, anyway, I need to now create the inverse graph and see what is reachable from n+1. That cannot have cycles. Why it cannot have cycles? Because everything has input degree equal to 1. Okay. So now there is this thing. Inverse graph. Inverse graph. I plus a of I. If this is smaller than 1 or bigger than n, then we have that fake node. I called it n+1. Maybe 0 would be better, but let's be consistent. And edges of j push back I. How we will do that? I want a set, right? Yeah, sure. If not visited. Sets are very slow, but if data is small enough, they are convenient. Edges of A. Let's call them good nodes. DFS for what? For n+1, good. We here print good as well. Including n+1, those are such nodes that from there we go outside. Now, first, if something is a cycle, I want for all the cycle nodes, I mean just for all the nodes that are visited in the first path, and that was called k. For each of them, we can go to one of the good nodes, where n+1 should be treated as something like n different nodes, because always we have 2 times n+1 possible moves, including n valid moves, meaning n moves that will move me into the sequence from 1 to n, and n+1 fake moves, meaning we go outside. So this should be increased by n, because not only there is n+1, there are n other places for that. And every such move should do the job. And actually, otherwise, for now, let's print the question mark. 2, 6, and 30. 2, 6, and 30, that works. Great. Now, this is not a cycle. But a path. And let's count bad cases. Bad cases are those, but also from them moving into anything that is bad. And that's like n+1 minus good.size. This is the number of nodes from which you will get to n+1. So this is the number of nodes that work in cycles, I think. $34 and $20. The last case is incorrect. Yes, sometimes it's too low, and sometimes it's too low. That would be an overflow. Started this statement for the last 30 minutes. I would understand doing that for a problem like C, but for D, for this problem, for me, it's obvious from the first moment that we should analyze, cycles. And this is a problem where you shouldn't be stuck after reading the statement. It's okay if you cannot solve it, but it should be obvious for you how to move forward. And otherwise, it means you didn't solve enough directed graph problems, which you can say about almost about any topic. Nodes going in cycles. Let's print that. What's the smallest invalid test? 2867. Fourth test. Let's focus on that. 1, 2, 3, 4. Oh, they can. Okay, cycles can be included here. But this is that case. What's going on? Five. It should be 7. But this is the cycle case, right? Oh no, they are moving forward. So what is bad? Bad is 1. Why is bad 1? Good, 2, 3. Why doesn't good get into 1? The edges should go 1 to 2, 2 to 3. From 2 to 1, from 3 to 2. Something is wrong with my DFS. What a beautiful DFS function. Well, great recursion I have here. Without recursion. Good that I added something to visit it. Oh yeah, I see. I added to visit it instead of running DFS. Adding to visit it happens here. Good DFS. Two, 8, 6, 7, 20, 18, still bad. 35, 34. There is off by 1 error here. Fourth from the end. This one. Well, this will not be easy to debug. Printing 18. It should be 17. Of 1 DFS. Yes, it was well optimized. It's actually not O of 1, it was O of number of neighbors of the first node. So O of degree of one node. So you know, linear. Okay. 1 goes to 2, 2 goes to outside, 3 goes to 2, but that goes outside. Oh. That might be a big issue. So this is the test, and I'm assuming that there is a path and there is almost no way to mess this up, but actually you can change this edge into that, and that will create a cycle. So if you have a good path, you can still mess it up by creating an edge from something on the path to a node that uses the path. And this, in my opinion, is difficult to detect properly. Did people solve it at this point? Not necessarily. Okay, so I wouldn't see that many submissions. Okay then. I wonder if this issue only happens for a path, but I think so. So first of all, if we have this thing where I go into a cycle, now we're saying that I want to change one of them to go to the outside world. Yeah, this case I think is okay. But now, what happens if there is like something like this? And now I'm changing, let's say 2. I'm changing 2. 2 is maybe not the best example. I'm changing 3 into something that so far was good. I can solve it in quadratic time, but that doesn't help much. So it cannot now lead to such a node that from it we get into 1, 2, 3. If there is here node, call it V, and it gets into the 1, 2, 3, that's a cycle. So for every node in the graph, I need to know where it enters this main path. Let's call that main path. So what do I do for that? Is that still backwards DFS? I think so. I will run backwards DFS for 1, then for 2, then for 3, and so on. And I will this way count the number of nodes. that are like predecessors of one, or whatever the word is. Can you run something like topological sort? Yes, but still I want to understand the structure of non-cycles. Even if there aren't any cycles here, even if this graph is simply directed acyclic graph, then not only I want topo sort, the topological order, but I want to know where they enter those nodes. Okay, so now when I find a good path, and I think I did that somewhere, okay, now there is a case of non-cycle. No, I already have that. Let's say visited clear, because I think we have something like that, right? Yeah. Now, for everything in the path, assert that it wasn't visited yet, because I don't know how it could be. DFS of A visited. This is DFS on the inverse graph. And it goes backwards. That's great. I also wanted to count things. I run DFS somewhere else. Here. I don't care about this value. But here I do. Because now I want to say that the answer and all minus equal previous. Those are nodes reachable from A backwards. And this will get bigger and bigger, and that's fine. Then I don't need to subtract that. I think that's it. Previous is keyword. No. A was used. $21. That's bigger. It was supposed to be 17, right? 17. But what's the test? Test is so simple that we can just print. For 1 the previous is 0, for 2 the previous is 0. That's not correct, because we are not increasing the count. 17. 34, 30. Let's save a file and do the diff. Yep, that works. That's a time of 1 hour. And I think that I should be able to submit now. No, you should be registered for the contest. Not yet. How am I doing? Please mute stream elements. Oh, you mean in the chat? I don't remember how to do it now. After the stream. I mean, Okay, my performance is top 100 so far, it seems. Yeah. Let's move to E. Stream elements. I don't remember in stream elements where I'm setting that up. I'm now looking at my commands, like in exclamation mark something, but yeah, after the stream. I'll not turn it off now. Do I do rough calculations on pen and paper when not streaming? What you see me drawing, I normally do on paper, if this is your question. Maybe I'm here explaining a little bit more because it's a stream. Trick problems? Yes. A, B, C, D. ABC I didn't like too much. D was a good problem. More case analysis than algorithms, but I also want sometimes a more standard problem. But like, figure out how to use a segment tree, stuff like that. XOR in every subsequence is X. Oh, numbers from 1 to n. This is what people usually call a constructive problem. Will you get time limit exceeded in B? What was that? For factorization, you used a map. Should be fine. Map isn't a bottleneck anyway. The bottleneck is finding divisors. So I think by using map, you shouldn't get any worse runtime. This for loop is a bottleneck, and it doesn't use a map. What happens here actually, I think, happens fewer times. So first of all, I'm guessing that x is either 0, no, not 0. X needs to be XOR of just all the numbers from 1 to n. What's XOR of numbers from 1 to 15? Well, that's certainly not 7. Hmm. 12, 15, 6, 7. Oh, XOR of everything is here 0, and then you can split into 6 buckets with arbitrary XOR possibly. Okay. If k is odd, here, if k is odd, then XOR needs to be just equal to XOR of everything, otherwise it will not work. Here the answer is no. In the next test the answer is yes, and I'm guessing that 1, 2, 3, 4 XOR is 4. Yep, because of the parity. Okay, let's experiment. We have numbers, let's say up to 7, and I want to split them into maybe 2 groups, maybe 4 groups, with the same XOR in each of them. XOR is given to us. For every bit I can count how many times it is 1. And there needs to be some divisibility possibly going on. So right now, or maybe right now, the number of bits for every position, that's 2, 2, and 3. And I'm guessing that then, like always, the answer is no. But why exactly? Well, only the parity matters, so it's more like 0, 0, 1. Right? Is it that important that those are 2 to 3? Not really. All the numbers up to some power of 2, they are arbitrary and very flexible. I think now that we should split greedily those elements. I mean greedily, in any way. Big elements, those with value 1 at the beginning, with bit 1, we will split just in an arbitrary way. Maybe even all of them should be one group. And then here we have all the numbers of all the binary masks of some length. Oh, but they do not affect the first bit. So those we need to split in such a way that the first bit is okay. Then those we need to split in such a way that the second bit is okay. And so on. We have number x, the target. Let's say this is x. If we want 1 on the first position, let's say k equals 2, then one number needs to go to one group, one to the other. On the other hand, if this is 0, they both need to get to the same group. If k is big and eventually we'll get only few numbers with 1 on this position, we will not be able to distribute it properly. So should we always like maximize the number of other satisfied elements? Can I submit already? Yep, I can. I will prepare all my submissions to do it in the same second, 1 second apart. I wonder if hitting enter is faster. Well, it's not that important anyway. I think it's very difficult to submit in the same second a lot of files, right? Oh, the second is not displayed. But notice that I didn't get 4 submissions in a row. Between my submissions, somebody submitted 562. Okay, in A, I got wrong answer. Maybe because of those powers. Should I just say -1 otherwise? Maybe I made some mistake there. Okay, so my logic here was wrong. Okay, I'm very stupid. In my formulas, I didn't include times y and times x. So this should say times y, and this should say times x. It should never happen, but earlier, just incorrectly, my program thought that some extra equality is possible. Yeah, here we go. So one easy to fix wrong answer on A, but also chat spoiled to me that this is the only possibility, like even n. I knew from the chat that the only case is unnecessary. Also, I suspected that once I realized that this is one possibility and this is problem A. Okay, back to E. I'm at 1 hour 13 minutes. Maybe after splitting those, we should look at all those numbers and do something with them. Or maybe I should instead think for what k and x this is possible. Maybe figuring out yes or no answer is crucial. But I don't see how. Like it's difficult for me to say if k equals 3 versus k equal to 5. Like if one is... Certainly if we can split into 5 groups, we can also split into 3 groups, because you just merge 3 into 1. But how far can we go? So maybe I should think, for given target value x, how do I maximize the number of groups given a parity of k? If x is this, I can pair things up, this with that. So it would be best to group elements into pairs, but not every element will have a pair. If x has 0 here, then what? Then elements here can be paired up. Let's say that element 0 also exists. Then those can be split into pairs, and we have those elements, and they will mess things up. They need to go in as pairs, So if I combine that as a pair, it will be like an extra element 0, 0, 1. This is just a combination of those two. And now this becomes unsolvable. Unless they grouped into 0, 1, 0, then it's solvable. But maybe some of those should be grouped with some of those, not as pairs. Every non-empty group should include one of those at least. How often can one of these be matched with two of those? And does that help? Doesn't really. Now my guess is that everything with 1 on the first position can be grouped together. And if that is equal to x, then the answer is yes, otherwise the answer is no. And here I can try to group them into pairs, but it's like a smaller problem. I can remove the 1, run for those, try to pair them up. Let's solve this recursively without this 1. But what if x has a 1 here? Then every group needs to include at least one of those. I think it will include exactly one of them. How do we solve this? Hopefully this is one group, this is the other. And we have some target values that I want to get from these guys. I need to group them into 2 such that one group gets a particular XOR. If those are different XORs, then I can just, for this one, greedily assign one of those values so that the XOR would be X. And for this one, everything else should work. And again, I assume that 0 exists. But I forgot talking about the parity of k. But maybe always just one parity of k is possible. K is even and x is 0, or k is odd, x is XOR of everything from 1 to n. Now if k is odd and we're looking at the number of those big elements, this will automatically work. The parity of ones here on the first slot will equal to the bit here. So maybe this will be the situation. And then each of those I will pair up like this with 1, 0, this with 1, 1, this with 0, 0, and everything else should XOR to 0. I will add it to any group like this one. So in this case, if x has 1 on the first position, problem solved. if x has 0 on the first position, but still some bits, and k is odd, I think that's possible. Well, not possible here. No, it is possible. They can go together. Then I pair those up. Every group needs to include at least one of those. Pairs. I'm hoping that those are useless. I understand that what I'm talking about seems chaotic, but I don't have another way to solve the problem. This problem is a lot of analysis that the things I say out loud are simplified. K is odd. I want to maximize k because grouping into one group is easy. For 3 maybe it's slightly more difficult than 5, 7, 9. It's more and more difficult. Basically I'm finding for given n what's maximum number of groups that I can achieve and how to split into those groups. Decreasing number of groups later will be easy. If those two go together, they will pretend to be 0, 0, 1. But so what? If I want to use those guys and they need to XOR to 0 and something, I always need to choose at least a pair of them. Like 2 of them and then 1 from here. I'm tempted to say that as well we can use all of them at the same time. I'm hoping that using only some of the numbers with 1 at the beginning doesn't help too much. If I group all of them together, then they will turn into some number, and they will turn into 0 because I know, no, they will turn into x, because XOR of everything here is simply 0. Unless length is 1. There is some special case when length of x is 2. 0, 1, 1, 0, 1, 1. Okay, so assuming that len of x is at least 3, or len of all the numbers, then for this to be true, x needs to be equal to XOR of all of those. But can I also group them internally? Oh, but that's what I said about removing the first bit and continuing recursively, with information that an even number of elements needs to be in every group. This is just 0, 1, and here I will choose 2 elements. But if I try to like split those into groups, I will anyway use pairs, right? This gets paired up with zeros. When don't I use pairs? If I include 0 in my sequence, then here's a simple lemma. No element will be alone. And second lemma is that sometimes I can say that groups will be of even size. That would help a lot with going recursively here. I mean, if that's the situation and there is one element here, oh, but we are talking about 0 at the beginning, then that's impossible. Also, does something change for this case? It does. Now k is even, x is 0. But right now the XOR of everything is not 0. Can we say that this is possible only for powers of 2 minus 1? But even if that's true, then how do I split things? Everything will include at least 3 elements. How do I split numbers from 1 to n into groups with XOR equal to 0? I think I will split like that, and always it will be 2 from one group and 1 from the other, but also not always this is divisible by 3. Groups of 4? Groups of 4 would be easier, but group of 3 sounds better and sounds possible. Maybe there is a way to explain why groups of size 3 shouldn't work, because I can show a triple like this that works. Here is another triple. No, this is not a triple. Those together would need again 0, 0, 1. But maybe something more crazy like this, this, and something else. Groups of 4 would be so much easier. When you choose 2 random values, the third one will be something else and it will be valid. 2 from here, 1 from there. For every column, meaning for every bit, 2 numbers need to have a 1, or all of them can be 0. This is an example triple. I will write down the statement at the top. Split numbers 1 through n, or maybe 1 up to some power of 2, into triples with XOR equal to 0. That's what I'm solving now. I can implement a brute force. A brute force that will consider all the splits of numbers from 1 to n. It will work up to 15. I don't need to implement a brute force because this is a good test. Now I wanted a test where this is 0. Can this be 0? It should work. X is positive. I'm for the past multiple minutes, I'm thinking about a test that is not allowed. X is positive. Okay. Well, then Control A, delete. If k is even, why did I say that? If k is even, then x can be actually anything because it cancels out, but it requires n to be of such a form that XOR is 0. And I think this is only possible for such n's. Still, it's a similar task, because we need to split into triples if possible. Like here we could split into groups, into 6 groups. That's a difficult test. So the task is I think that's what I'm solving now. There is even number k triples or so. K is even, and that's the target. XOR will cancel out, so we want XOR of everything to be 0. Seven doesn't have the first bit on, so they are using pairs of numbers bigger than 8, or just everything smaller than 8. For any two numbers, there will be a third number that matches them. Just A XOR those two numbers. What we don't want is any kind of repetitions. The final three elements will always have a proper XOR. But the second to last triple will be difficult. One hour, 40 minutes. Some people solve this task in 10 minutes. Wait. If XOR is non-zero, then maybe what I can use is pairs. That, of course, would be better. Oh, I'm so stupid. Splitting into pairs is trivial, right? Everything will have a pair. Okay. Then I can overshoot with k, but I can always group things together. So if k is even, still I hope that this is true, otherwise the answer is no. But the answer here is yes. This is actually independent for both groups, for numbers bigger than 8 and smaller than 8. Maybe we will recurse for those. Is backseating illegal? I don't want spoilers, so please no. If you're seeing something bad in my logic, in what I'm saying, then you can say, let's say. But you cannot provide new ideas. So don't provide new ideas, you can say when I'm mistaken. Check number forward and backwards. I don't know what number. I need to split a group of numbers. So. Okay, this is, but I hope that the answer is no. Well, I wanted to get the XOR. Zero. Oh, XOR of everything is 0, not just for such numbers. So let's ignore that. Still, maybe just everything has a pair with XOR equals 5. No, 8 XOR 5 is 13. So I cannot split using pairs. Eight, 9, 10, 11 are 0. So that's nice. All the numbers up to 7 I can split into pairs, including a pair 5, 0. And then bigger numbers Enjoy the drama about this E? Is it so bad? If it's a well-known problem, then of course there should be drama. But if not, then I don't know. It's not that I love the problem, but so far I don't see anything wrong with it. Can we say that if this is too big, then just group 8 up to n into one group with XOR equal to 0? Not necessarily, I think. I believe that the number needs to be n plus 1 should be divisible by 4, I currently claim. Not well known, but there are debates about certain way to solve it. Sounds like a random solution. But, you know, if you here get the idea of implementing it randomly and have some intuition about it working well enough, then that's, I think, a valid solution. It's not that, if my intuition didn't tell me that your randomized solution makes sense, then that's fair. That's a bad intuition. I wonder, though, if that's a good solution. And if I properly interpreted your message. This should be X. So 4 consecutive numbers will XOR to 0. Okay. But if this is true, and by that I mean that biggest power of 2 or something like that, still they can be of some use. Can get back to the idea of solving this randomly. Okay, what about so split pairs, so create small pairs, then cut the first bit and everything else go recursively with a requirement that every group should, then we're back to just this analysis, right? Then we set case odd. I feel like I'm going in cycles or circles. It's a past problem. Yes, it's a past problem from 2 hours ago. This was TypeDB Forces 2023. There is even an editorial, but I'm not looking at. Oh, there were prizes. 50 hoodies. That's a lot. Hoodies are rare. T-shirts are very common. It's a pity I couldn't participate. Not that I would necessarily get to top 50. Okay, so back to this. Now, case even. X is greater than 0 because that statement guarantees that. It can arbitrary. I had that analysis. So what if this is x versus what if this is x? Now I need to apply it for even k. Every number from here should be grouped with one of the zeros. So that's easy. Because for every number with 1 at the beginning, there will be greedily chosen one of numbers here, and that's the limit. I cannot do more. Now for that case, I can group them into pairs. And generally pairs are very good. And then I can cut one, go here, and say that always group size needs to be even. I don't know if it's optimal. In particular, we can take all of them and add just to anything. Because XOR of them should be 0. Well, it's divisible by 4 in particular. Well, I hope this will work. So time to code it. This case is trivial. This case I will greedily split them in pairs. 0 pairs, 1 recursion. This, and here it's just 1 with 0 pairs, else all together. That's for even k. Oops, and did I just apply the same for odd k? Not really. For odd k and particular XOR target, if 0 is at the beginning, then we do the same thing here and the same thing there. And if it's 1, then the same logic. Okay, it seems that k isn't so important. The parity of the number of groups will be important though in one case. Well, let's implement what I have. But it seems that I already had that a long time ago. I don't know. X is here huge, but it can be decreased to twice n. No, you cannot get such a big XOR. We will have a recursive function that returns a split into groups. It will split numbers from 0 to n. I didn't know that I can have alt and smaller than will give me smaller equal. This number 0n we will split into not even k groups. I think it will be just as many as possible, and the parity maybe will work. So I'm looking at the first bit of x, and that's the most significant bit. No, I'm looking at the most significant bit of n. First, if n is equal 0, return. I'm not sure, but this bit is the most significant bit of n. and I have cases for whether this happens or not. Also, if any other bit in X is turned on, that's impossible. I don't need recursion, do I? Because for every bit we will just once recurse. Or whatever, let it be a recursion. I'm tempted to say here that if X and this, then there is no solution. But I don't know if this not necessarily means the same thing as here. We'll figure this out. If there is 1 at the beginning, then everything with a 1 needs to be paired up with something with 0 at the beginning. So for in particular, this is a power of 2, like let's say 8. And here I need to iterate numbers from 8 to 9. And groups push back as just a pair I with I XOR X, and I claim that this will be small. 2 means a power of 2. Everything else, everything small, can just go together. Groups, so there is like last group. No, not last group. I just need to add them to something else. So groups dot back, push back a useless I. Okay, else if there is 0 at the beginning of X, then I'm grouping zeros into pairs, and ones I need to run recursively by first cutting that one. Like that, and here solve for n-2 because we turned off this bit and is smaller now. Also X has that bit turned off. Okay, I don't know why I'm passing K, but here you go. Done. I need to run it. And print it. I will do a colon just for clarity for now. Erase colon. Okay, shadowed, that's fine. I don't know what is happening for very small n, but we got something. 07162534. That's good, but I also want to use big numbers sometimes. I do not check if this is a valid split. That will be later, and for now I'm ignoring k, but numbers from 0 to 7 were here split properly into groups with x are equal to 7. Then we have 8 and so on, and they can be grouped together apparently. So what do we do with them? If this bit on, not this bit is not on, we, oh, I see, we run a recursion, but I'm guessing that this is empty. Yep, that's empty. We run it for n minus 8, that's 7, k, and minus 1. X anyway had 0 there. Okay, cool. There are some numbers here. And we need to have the condition that for every number in that group, we need to increase it by 2 because we shifted everything. What is warning? It's exactly what the name suggests. It gives you a compilation warning so you wouldn't forget about something. 12 and 11. Seven. That's correct. Okay. Now, if we have too many groups, we need to decrease the number of them. How many? This many last groups, I think we want to merge into one group. Can say here this. So that many times I'm grabbing the last group, I'm inserting it to one thing, v.pop back, and this, not groups, that's called v. And do we have 6 groups? 1, 2, 3, 4, 5, 6, 7. Nope, we don't. The formula is wrong. Oh, of course. I need to just remember something here. Diff. Oh, but I have count. One, two, three, 4, 5, 6. Okay, now we need to remove a 0 and then check if this is something valid that I should print. In the second test there are 4 groups, but I'm not returning everything. I think always when we have recursively, when we get something empty, we should just dump everything. There. Here. If v empty, then everything up to n groups back push back I, because you didn't succeed. And I'm still not checking yes or no, but this will be our best bet. And then at the end I will just verify if this works or not, where else the answer is yes. In the third last and fourth last test. This is the last test, this is the second last test. Oh, just one group with 7 elements. With 6 elements, yeah, 0 will be erased, that's fine. And here also one group, so that works. Fine. Now, I think always I include everything, unless x is too big. X is too big. And then it's just completely invalid. Well, if this thing returns empty in the first iteration, then it's actually reasonable to say that the answer is no. Which can happen if x is just significantly bigger than n. So let's try 11, 6, and 100. What does my code print for that last case? Nothing. Good. Now, for every group, let's compute what we need to compute. No, we need to print no. We print yes, removing the colon, and just 0 needs to be erased. That's the last thing. Too many yeses. I will fix that in a moment. Oh, right, okay. If v empty or the size is not k, let's just print yes or no for a moment. Yes, yes, no, yes, yes, no, no, no. Good. And I don't want a 0. Positive. Actually, just let's not push back. No, I don't want to modify that other code. For everything in group, if it's non-zero, positive pushback. and group becomes positive. Okay. Let's submit. I'm at 2 hours now. Accepted. Okay, that was at the end very easy. I wasted a little bit of time, so because I'm writing down times. That's 207. I wasted some time on x equal to 0, which was impossible. And it's still not clear to me why this works. There was some guessing there. Whoa. Make subsequences in the form of pairs a XOR x as much as possible. Leave x alone if possible. That's a simple solution. So the drama is about whether this is a guessing problem or not. For every number that has the most significant bit in x, you can partition it, or you can pair it, and every group must have number with that most significant bit. That has the most. I'm thinking. Wait. It cannot be that simple. I mean, it apparently is, but most significant bit in x. So it was wrong of me to look at most significant bit of n instead of x. If we look at most significant bit of x, then I agree that we need such a number with 1 on that position, and it should be paired up with something, and that something will be smaller, so it exists. I see. Okay, that's a good description. How to start in LeetCode? I don't know, there are so many articles online about how to start. Go for easy problems. Read editorials, read codes of others. Okay, so if x is, let's say, 0, 0, 1, whatever, and we're looking at number like, let's say, 1, 0, 1, and whatever, then this XORed with x will give us something smaller. This is our, I don't know, I. Now x XOR I is 1, 0, 0 something, and this is strictly smaller than I, so if I exist, then this exists. And that's it. Everything not paired up In particular, something will be paired up with 0. Then everything not paired up should be just added to one group, and it works or it doesn't work. That's a valid proof. I understand why it works. I understand why the greedy solution, not mine, works. Now, is that bad? I think that such problems are perfectly fine in ICPC, and in Codeforces that they add a lot of variance to scores, because in ICPC you have 5 hours, a lot of teammates, a lot of problems. It's fine if some problems are like that, where you can solve it in 5 minutes and take a guess. In Codeforces I would prefer to avoid them, but if it's one problem out of many, still, because of increasing difficulty, every single problem will be, for hundreds of people at least, the most important problem in the competition, deciding about their place, like if they take position 500 or 5,000 maybe, not that much, but 500 versus 1,000. But I think it's fine. I spent a lot of time, an hour, solving this problem, and I don't feel so bad about it. But I also understand if people do not like it. So do I think the problem is too easy to guess? It's possible to guess, and many people will guess, but it makes it not a great problem, and that's it. As a Codeforces coordinator, if I was a Codeforces coordinator, would I discard that problem? I think I wouldn't like it, but I wouldn't disqualify it. Still, if I am to vote here, like upvote or downvote the problem, maybe downvote is better, more suitable. What is a great problem criteria? It's complicated. It should be nice, like amazing to solve. There are some blogs in Codeforces about it. I'm sure also with my opinion on that. Okay, and let's try one more problem, because I wanted to do that. I wanted to do F, even though I'm more than 2 hours into the stream, and as well I could finish now. Let's see what that is. Maybe I will just give up. What is F? AX is a permutation of a single number. AX is a single number. For every number we compute when it gets back to its position. So is it just what's the cycle size, or is it something else? Yeah, I think it's cycle size. What is K? Oh, I see. We are given I need to find such permutation that this permutation to the power K is the one in the input, and I also minimize the sum over inverses of cycle sizes for every element. Isn't that just the number of cycles? Yeah, 3. This will always be integer and always number of cycles. If you add k number, if you sum up k numbers, each of them 1 over k, then it will be just 1. So here they are saying minimize the number of cycles. I hope, I think. Should I draw this? What is k in the second test case? K is 2. 1 to 6, 6 to 1, 2 to 2, 3 to 5. Wait, no, I mislooked. 1, 2, 3, 4, 5, 6. Oh, on the second day means actually on third day. K needs to be increased by 1 immediately after reading, I think. Let's draw that to make sure I understand correctly before I start solving it. One to 6. This wasn't an efficient way of drawing that. 1 to 6, 6 to 3, 3 to 5, 5 to 1, 2 to 2, 3, 4, 4 to 7, 7 to 4. That's it. 3, 2 to 2. So I think it's not really raising to k power, but k times squaring it. Yes, we don't do that. Okay, so it's not permutation to power k. It means squaring permutation that many times. So if cycle size is 4, then squaring it 2 times is enough to make it into identity. Still, we need to minimize the number of cycles. And this is 3 because that's the number of cycles. Cool. I don't think all of that was necessary. The step about understanding what this formula is equivalent to is easy. So I don't know why bother making this more complicated. Can't they just say here number of cycles? I guess then it requires definition of that. But everybody who tries to solve this problem understands what is a cycle in a permutation. This thing is a bad ratio of like how much to explain in a problem statement versus how much time it takes to understand, to solve that part of the problem. Okay, now we are given a big K. We're give K. Let's see what happens when we have, let's say, cycle of size 5 and we keep squaring it. One will go to 3, right? 3 into 5, 5 into 2, 2 into 4, 4, 1. Then 1 into 5, 5 into 4. Then 1 into 4 and so on. Always the day 0, day 0, 1 goes into 2. This is day 1. Then this is day 2 and so on. On the cave day, we have like everything goes forward by 2 at power k. And we what is here important is to cave power modulo the cycle size. So for cycle of size 5, we will never say that 1 goes into 1. If we are given k, we can iterate all possible cycle sizes from 1 up to n, and for each of them compute what this is. And then we will check whether it's coprime with cycle. If cycle is odd, then it's always coprime. Is it? It's like checking if 2 cave power is coprime with cycle, I think. But if cycle is even, then it will decrease a little bit. Now we want to minimize the number of cycles initially. We don't want a lot of them. So if we're given something, let's see, the number of cycles here with every power decreases or increases? It increases, because a cycle of size 4 would be split into 2 things of size 2 and so on. Or if we have cycle of size, let's say, I don't know, 20, then after one move we have 2 cycles of size 10, then 4 cycles of size 5, then 4 cycles of size 5, and so on forever. I think that's the case. So for the when k is up to 20 or so, something interesting can happen. I believe that bigger k only shifts things around. Now in the input we have cycles of different sizes, and we can group them. So if in the input, let's say I see 7 cycles of size 5, and also k is equal to, let's say for now, 100 or 1 billion, it is possible that 4 of those cycles were initially a cycle of size 20. I just need to combine them in proper order, and finding the proper shift will be annoying, but possible. Now the other 2 cycles, should I also say that initially they created cycle of size 10? I think so. And if k is, let's say, 1, it means this happened only once, so only 2 at power k is possible. I think there will be the following part of logic. If there are, let's say, there are a cycles of size b, then 2 at power k. Does that matter if this is even? And can we say no? We can say no. If this is odd, then everything is fine. But if cycle size is even, then there is something special where every turn so far it needed to be halved. Okay. If b is even, then a must be divisible by 2 to power k or so. Otherwise this doesn't work. Then what I do is for j equals minimum of k and 20 up to 0, well, 2 at power j fits in A. Does that make sense? Subtract that. And this is a single group. So one big cycle of size A times 2 at power j. I need to find those cycles, combine them, find proper shifts, and that will work. Seems easy. Much easier than the previous problem. I think I will first start by implementing this just to get yes, no, and then to print the cycle sizes, and then the last thing will be to add shifts. I will copy this. Again, very strong samples. Because the Codeforces community likes strong samples. If I was an author nowadays, I would also do that. I don't think that it's good. I think that this shouldn't happen, but people like it. People never complain about strong sample tests. Input vector from 1 to n. I want to find cycles here. Does DoorDash exist in Poland? I don't think so. Not visited, then we start a cycle. Eventually I will need to find that cycle. This is in of j, also visited. We found the cycle, cycles of cycle.size, pushback cycle. I group cycles according to their size. Still wrong. Cycles of 0 should be a vector of vectors. Oh yeah, there's too many characters here. In the second test, out of cycles of size 1. Oh yeah, because that's identity. In fourth test, something more interesting is happening. 4 points to 4, 1 to 6, 6 to 2, 2 to 3, 3 to 5, 5 to 1. Makes sense. Now, if there are A cycles of size B, If b is even, if a modulo 2 at power this, okay, but k can be decreased down to 20. If this, then print no. No and no. Okay, that seems correct. Then hello Adamant. Now let's try to figure out those cycle sizes. For everything. Cycles of size A right into that. Four cycles of size 1 combined into 4. So maybe second test is more interesting. 4 cycles of size 3, what? Of size B, what is A? A is the count of them. B. B. A is the total number of them, so it shouldn't matter too much. Four cycles of size 1 combined into a single 4. So this is that thing. 2 cycles of size 1 combined into 2, and this. And 1, 2, 2, 3, 4, 5, 6, 7. No, not this. 1 to 6, 6 to 1. 2 to 2, 4 to 5, 5 to 7. 7 to 4. I didn't see correctly, but I think it's okay. We properly print the cycle sizes. Xardas, don't ask useless questions. Yes, you can be top 10 in Java, but what's the point of such a question? Now I don't want to use A. I want to use this. just fixing indentation. I grab the last cycle, I push it all to one big thing, then I remove that cycle. That many cycles of this size combined into that. And when I'm done, this should be true. And when I create big, can have this. And the last remaining thing is to order big properly. Why is it so long? Oh, because I'm printing empty stuff as well. No, it's not because of that. Now, we need to use 2 at power k modulo the big cycle size, or what? Yes. So let's compute power of a at power b modulo mod. Mod will be the cycle size. And I hope it's bigger than 1. Maybe not. This will be 2 at power k modulus big cycle size. For every position, if it's empty right now, how do I use those? So I have a cycle, let's say that I'm looking at a cycle like 7, 10, and 5. Now it needs to be part of a big cycle. The 7 will be on the first position. What does it mean that 7 is on the first position? It doesn't work like that. 7 means 7. So this means starting from index 7, 7 points to 10, 10 points to 5, 5 points to 7. Now in that big cycle, seven needs to point to something, then that thing points to something else, and so on. So we need to gather first elements, then second elements, and so on. Count. So I think that big of 0, what's the size of everything? S is the size. Big of S, big of 2S, and so on. It will be big of 1, big of S plus 1, and so on. That's the cycle now. Starting from I and increasing by S. Now this is a proper order. There is also the shift. Why did I do this? If shift was 1, then is this correct? Yeah, what did I do? Do I really care about my rating in Codeforces? Not much. If I did, a long time ago I would participate to get the Nutella rating back. I'm just below 3000, I think. And that shows how little I care or cared. People usually get the high rating and they stay there, they do not participate. My rating, I dropped from a higher, bounds, and I didn't try to get it back because of the lack of time and motivation, but it shows that I don't really care about Codeforces rating. So if this is a cycle, and there is this shift, how are those two things connected? I think I need an example. So let's say that there is a cycle A, B, C. There is another cycle D, E, F. Do I want to draw 4? I guess so. Okay, 4 cycles of size 3. We know that we're looking at we want to create cycle of size 12. This is the big cycle. And we'll compute some kind of shift, saying in that new thing, so it has, let's say, 11 slots. And if number A is somewhere, then, and shift is, whatever it is, but shift is 2 at power k modulo 12. Does that mean anything? Can it be just 2? Or 4? Or 8? 16? I wonder if this is always valid. but I will put a here, whatever that means. And then let's say shift is 2. I will put B here, I will put C here. D, E, F, G, I, H, I. So for every new cycle, I need to find the first slot that is available. And take those. And then finally, once I have that cycle, what do I do? How does that affect what I print? 0th element of a cycle, it just means something is there. And that means answer of A equals D. And so on. So I need to say answer of cycle of 0 equals cycle of 1, and so on. Okay, I will try doing this now. So was this important? Did I do something smart here? I think not at all. I didn't really need big. What do you want? Unused. Unused is fine. Big of this size. While initially, let's fill this with -1s. I have a sequence of 12 -1s. While big of next is equal -1, next plus plus. And then I can start using from here forward by shift. So I don't know, current is next. Big of current is Z, should be -1 a moment ago. Current is current plus shift. Okay. And now answer of big of I is big of I plus 1. I wonder if we'll get assert. Oh, no, that's not it. Is big possibly greater than answer? So is size bigger than n? That shouldn't happen. Let's see. GDB, run on the input file, line 92. Okay, that's suspicious. Big should be enough to keep everything. Count is this. What's B? B is the size. Big should be. all minus ones. Next starts as 0. While it's not minus 1, of course. Let's see the second one. Do we have here those cycles of proper sizes? 1 to itself, 2 to 3, 3 to 2, and those go together. Well, let's submit this. In Codeforces, you don't get a time penalty for a wrong answer on first tests. Easy. Okay, so that took me 45 minutes, minus some stream time. After solving E, I read the tutorial for E. So during a contest, I would solve this in half an hour easily, which is certainly better than my performance with E. Well, others were faster with F, but could be worse. Okay, that was 3 hours of a stream. I still need to do G. Let's see what did I recently do. Here I want to look at G and H in the future. This is wrong answer. I didn't solve something. What? I thought that I got it accepted. Maybe there was a rejudge and I just need to optimize it a little bit. Didn't I get accepted in E? I have a recording. Accepted. Here you go. Oh, I see. Accepted 2449 milliseconds. And now it's time limit exceeded. I failed sys-test, but I didn't. Oh, I see. In educational rounds, they add tests after 24 hours. Okay, so this is legit. Just after 20. This is how educational rounds work. Okay, then I don't know. Let's optimize this, and this will be the last thing for today. But I wanted to here go through what I did recently. In this problem, I'm not touching H2. Goodbye. Oh, and in this problem yesterday I solved it with DP. It was slow and incorrect, and still I need to understand how to do it faster. And G maybe is a valid solution, so a lot of upsolving. But I'm not that lazy with upsolving. Recently I upsolved all problems from some ICPC contest, so that's something. Okay, let's just squeeze this. For goodbye F, there's no complicated math necessary. I mean, the math that they used in the editorial isn't something that I don't understand. If you're saying that there is also a solution without such math, that's good, but I'm not touching that today. Lucas theorem. Okay, so Lucas theorem is fine. I used it in the past. I always keep forgetting about it. And I don't think a single time during a short contest I needed to use Lucas theorem and I came up with that idea. Which is bad. Maybe I should write it on the palm of my hand. This is eFast. Here I got time limit exceeded. I will grab the test. 2.7 seconds locally. Okay, now I don't remember what is a bottleneck. So let's first just remove that part extremely fast. Remove that part. That's already significant. What am I doing here? This. Divisors. Okay, let's not have set of divisors. Let's have a vector. Divisors pushback. Sort. And resize. To get rid of repetitions. .6, so already should be fast enough, but maybe this can easily be made faster. Not really. I mean, I can avoid map, and that's exactly what I will do, I guess. So this is tp of size divisors.size. I'm using here binary search instead of a map. That should be way faster. One second. Oh, and one other thing I could have simply used is that fast hash map. I think I have that in my GitHub somewhere. That, right, something like templates. GP hash table. So I wonder if using that instead of a map is already good enough. Copy. This is the slow code. I already got accepted, but I wonder if now we again should get 2.6, but now do this at the top. Int, but I don't want int. That should be fine. So just long int. Where is dp? Wait, that's my fast solution. I wanted the slow one. This is the slow one. Copy. .8. Okay, now this thing, hash table instead of a map, long type. DP, not M, wrong name. .1, so that's faster. I wonder if this is enough to get accepted. Still, I'm using set unnecessarily. Do I implement solutions after reading editorial? Sometimes. It depends. It depends on how complicated the implementation is, if it's something new to me, if I'm lazy, if I understand the editorial perfectly, if I have time. A bunch of people got 100 milliseconds solution. Why the button doesn't work now? Oh, here something is wrong with the chat because I cannot highlight a message. Was the message erased? By a message by Ariki. Arik. Interesting. I don't see it in that website for highlighting. I use this tool for highlighting messages, and in that tool, a message disappeared. This works. Huh. Strange. Yeah, in Twitch I see it. It does exist on Twitch. Okay. The thing is that the message was written by a turbo user in Twitch. Arik, can you type something again? Just as an experiment, I want to make sure that because of your badge on Twitch, I don't see your message in that other tool. And now somebody else should type something, or even me, ABC. I don't see my own message either. This is without the badge. Okay, without the badge I get access to, but also some other messages disappeared, like hello, hello, and ABC. So something fishy is going on. I wonder if the website works only when I'm focused on it or something like that. Well, anyway, please summarize F. What was F? My memory. This thing that goes in cycles. Okay, summary of F, and then I finish the stream. Too many tabs. Okay, so summary of F. What they are saying is that initially there were some cycles, like let's say A, B, C, D, E, F, and then multiple times somebody jumped like by 2 in those cycles. So here ACE would be created, and also BDF. Now we're given the final situations, like this, and we need to get the original situation also while minimizing the number of cycles. So if we see 2 cycles of size 3, we might suspect that initially it was a cycle of size 6. First thing is this, like we know that a cycle of size 6 would break into 2 cycles of size 3, but also more generally cycle of size K, not K, C, would break into 2 cycles of size C over 2, and so on. So when I see a lot of cycles of some size, let's say 10 cycles of size 7, I suspect that 8 of them are of size 7, but initially they were of bigger size. So I guess, and that's optimal, that initially we had cycle of size 8 times 7, needs to be power of 2, which is 56, and then that was 2 cycles of size 28, 4 cycles of size 14, and eventually 8 cycles of size 7. Plus there are 2 extra cycles of size 7. Apparently that was from a cycle of size 14. Depending on the exact value of k, some of those things are impossible. But I find cycles of the same size, like I see, in the input, in that final drawing, I see some number of cycles of size 3. Then I group them together into powers of 2, like I did here. I try to say maybe there are 16 or maybe there are 8 cycles of the same size. I guess that initially they were one big cycle, and I need to group them together in proper order. In the previous slide, here there were that analysis how we actually merge them, and like always, if we know k and we know the initial cycle size, that every element will point to element that is later by this much, 2 at power k modulo cycle. So this is what I call a shift, and I use a shift to combine things. Like if at the end I see ABC, then I know in the original cycle 2 positions after A there is a B. So I put A, let's say, on as a first element of a cycle, then shift elements later there is B, shift elements later there is C. I hope that everything will fit, and apparently there are some properties that make it fit. So that's the solution. And continuing the chat investigation, this is what I see, and so those 2 messages exist, curl of 3D exists, this thing is here. Uptime got ignored, but that's fine. I think my messages never show up. This is without the badge, but earlier there were 2 hello messages by Arpit and Codeforces fan. Maybe I was refreshing the website, this one, and maybe I need to keep it open for it to monitor things. So one more test. I will for now close this. Let's now test some stuff. Test 1, test 2, test 3 in the chat. So now the chat contains this stuff. Test 100, great. Now I'm opening the thing again. The website is called featured.chat. Dashboard. And we skipped all of those. Okay, in particular, when I refresh this website, I lose messages that would appear otherwise, which means this is not collecting on some server and doesn't run all the time, which makes a lot of sense. Only when this web page is open, this thing will collect messages. Good to know. Turbo test appeared, so my previous guess about the batch doesn't matter unless... Yeah, so that thing was stupid. Maybe I did something like refreshing the website and that was it. Okay, thank you for participating in this experiment with me. Now, that's everything for today. And next stream will be maybe tomorrow evening. On Friday, I'm going to that competition. So now, as I wrote in Codeforces, in my blog, where is that? I'm participating because of the competition in Poland, which is on Friday or Saturday. So I have until Thursday for practicing, and maybe like 2 more streams I will do, maybe 3. Maybe 2 streams, and also I will practice outside of streams. After that weekend, maybe I will do something else during streams. Maybe I will solve easier problems, interview problems, stuff like that. Tuesday I'm busy, so Monday, Wednesday, and I think that's it. Monday and Wednesday evening I should stream. Okay. Thank you all for watching, for commenting. How big is the event? The finals are small. It's for 20 people, but it's just the big competition where there was a qualification round, and only the best advanced to the finals. Still, for example, one organizer is Mateusz Radeusz, and he's better than me at competitive programming. So, even if I win, I cannot say that I'm the best in Poland. I will say that, but I shouldn't. Okay, bye.